differences and ratios of functions. Now, the first way we were able to tell whether or not we were looking at a linear function versus an exponential function is plotting the points. So you plot them, you look at the graph, you just look visually, what does this look like? Well, the next way we're going to look at it is from a table. And in a table, we have what's called differences and ratios. So in a table, if you're looking at a linear function, they're going to have a first difference, and that first difference will be the same. Okay, also known as, I'm just going to put here, common or rate of change. And actually, I don't like common, so get rid of that. What I really wanted to say was constant. Okay, now if you're looking at an exponential function, they're going to have a common ratio. So let's look at what that looks like. Number 2, tell whether the table of values represent a linear or an exponential function. Then write the function. So letter A, the first thing I'm going to look for is my x values. My x value, -1 to 0, then 1, 2, 3, increasing by 1. That's a good thing. If they're not increasing by 1, we kind of really can't do this. Then I'm going to look at my y values, and I'm going to say, okay, 32 to 16. How do I get from 32 to 16? One of the ways is I could subtract 16. Well, what if I tried to do that again? If I try to subtract 16 minus 16, do I get to 8? And the answer to that is no. So the subtraction method here, not going to work. So then I'm going to look and I'm going to go, well, maybe it's exponential, so maybe I have a common ratio. Common ratio means I'm multiplying by something. Well, 32 to 16, I'd have to multiply by 1/2. 16 to 8, multiply 1/2. 8 to 4, multiply by 1/2. 4 to 2, multiply by 1/2. So every time you're cutting the number in half. Now, the question is that a common difference or is that a common ratio? And that is a common ratio because we're multiplying. And if it has a common ratio the whole way across, this is exponential. Now, once we know it's exponential, it tells us to write the function. An exponential function is y equals a times b to the power of x. Now, remember that a is essentially your y-intercept or your start value. Like, where is the function kind of like starting out? Versus b is your common ratio. And then x and y, x is your input, y is your output, but we're going to leave those as variables. So we're going to have y equals a is your y-intercept. If you're looking for a y-intercept, that is when your x value is 0. So I go to my table, and right there is my y-intercept because my x is 0. So I'm going to have 16 times my common ratio, which we just found right here, is 1/2 to the power of x. Now, the question I always get and what you guys try to do is, should we multiply the 16 and the 1/2 together and make that 8? The answer there is no. Okay, do not multiply. One of the reasons I always like to say is because of order of operations. You always have to do exponents before you do multiplication. So this wouldn't work. The other way is if you multiply that together and you just make it 8, you have no way of telling what your common ratio is. You just lost it. And in fact, you made your common ratio 8, not 1/2. Long story short, that's your final answer for your function. Don't multiply the 16 and the 1/2 together. Letter C. Check your x values, -2, -1, 0, 1, 2. Looks good. Now we're trying to get from 6 to 8. I honestly don't know what, off the top of my head, multiplying 6 to 8, I don't really know, but I do know you can add 2. 8 to 10, add 2. 10 to 12, add 2. 12 to 14, add 2. Well, this is addition. So this is called a first difference. If you go back and look at our chart at the beginning, it's not a common ratio, which means if our first difference is the same, this is a linear function. Now, if we're doing a linear function, that's y equals mx plus b. And remember that m is your slope and b is your y-intercept. So y equals the slope. Well, the slope, you just found it. It's going up by 2 every time. So 2x plus our y-intercept. Y-intercept, same as before, it's when your x value is 0. So that would be 10, and that's the equation of the linear function in the table. Letter B, same idea. 0, 1, 2, 3, 4. That's all going up by 1, so the next thing I'm looking at is my y values. First thing I'm looking at is 0.5 to 3, and off the top of my head, I have no idea. So then I'm looking at 3 to 18, and I'm going, okay, well, I do know that one is multiplied by 6. So now I'm going to go back and check. I'm going to grab my calculator. I'm going to take 0.5 times 6, which in fact does get me 3. And then I'm just going to check the rest of them. So 18 times 6, yep, that's 108. And then I'm going to check again, 108 times 6, yep, that's 648. Because I'm multiplying, this is a common ratio, which means this is exponential. Then we have to do y equals a times b to the x power, which is y equals a is your y-intercept. Look at your table. That's 0.5. Times your common ratio, which we found right here is 6, to the power of x. And again, don't multiply those two together. You're all done. Letter D. -5, -4, -3, -2, -1. Looks good. How do you get from 12 to 9? Subtract 3. How do you get from 9 to 6? Subtract 3. Subtract 3. Subtract 3. That looks great. Because this is the first difference, I know that this is linear, which means we're working with y equals mx plus b. So we're going to have y equals the slope, which we found was -3x plus the y-intercept. Now, keep in mind, the y-intercept is when the x value is 0. So at this point, most of you are going to say -1. That's not true. That's when the y value is 0. I want when the x value is 0. Do you notice it's not in the table? Well, that's not a huge problem. We just have to find it. So -5, -4, -3, -2, -1, 0. Extend your table. And then -3, -3, -3, -3, -3, -3. So my y-intercept is -3. So instead of plus, I'm actually going to erase that and put a minus. And that's the equation of your linear function.